pulse, and we are sending 5 volt to 0 volt, and it is varying. Now, another important application of these pulses are for any industrial application. There might be any industrial application, or there might be at your home also. You will find out the application. That application you will find out in changing the speed of your fan, and also the dim light. Some light that can be used as a dimmer. So those applications are using this pulse width modulation. So what does it means? This width modulation means I am changing the turning on time. So this on time I want to vary. So modulation means changing the property. So this width of this on time I want to vary. That's why it is called the pulse width modulation. I am changing the width of the pulse. Now what does it happen if I change the pulse? Now if I have given two examples here. If you take a look, I have given two examples here. One is that this pulse width is reduced. So compared to the previous one, compared to this one, say for the first one, I have reduced this width. So here, this width has been reduced. Here, this width has been reduced. So what does it happen whenever you reduce the width? I can calculate the average value. So average value can be found from, so let me check whether. So if I want to find out the average for this duration, what would be the average? I can find out. Let's say I have given, I think, an example. So let's say it is the voltage is 24 volt, and I am making it on for only 5 seconds, and the remaining, this is the period, and remaining 15 seconds it becomes off. So if I do the calculation of the VDC, that is the average, then I can do the calculation by using the formula. What is the formula? Formula is I have to find out, so V average is equal to VDC, and that would be equal to how long does it on, that I will calculate. So that will be 24 volt, and it is on for, I will just make it. So 24 volt, and that is on for 5 seconds, right? And rest of the time, it is 0 volt for rest of the 15 seconds. And then I can find out the average in this 20 seconds. What is the average value of this voltage? So this is the average value I can find out. So from this average value, you can find out that this one would be equal to 0, and this one, if you multiply, that would be equal to 6 volt. So your average DC value becomes 6 volt if you considering that there is no off. So it is similar. This pulse is making 24 volt, making on for 5 seconds, off for 20 seconds. If it continues in this way, then I can find the average. This is similar to having a 6 volt of continuous supply. So 6 volt of supply will give you a power output to a motor that is equivalent to 6 volt. Now, if you change this pulse width, let us take another example. If I change this pulse width to say 10 second, so 10 second on and remaining 10 second off. In that case, this one will become equal to, average will become equal to 12 volt of continuous pulse. And that means I can change the voltage by changing the width of my turning on time. Okay. So that is the application that gives us the flexibility to vary the voltage across the load. So I can change the voltage across the load. And whenever you are changing the voltage across the load, if it is applied to a fan, that fan will vary, the rotational speed will vary. Now, if you connect this signal with a UL light, that light will be, brightness of the light will be changing. So I can use this as a dimmer circuit. So I can change the brightness of the light. So this is the application of the pulse width modulation. So the pulse width modulation is more applied in the industrial areas for controlling the speed of different motors. So this 24 volt, I cannot connect directly from the microcontroller, but I can, for this, we will be using a switch, a driver circuit. But this microcontroller will be producing these switching pulses. I can drive the switching devices from this microcontroller. I can show you one example from the data sheet. So we can go to a data sheet and find out an example circuit where your microcontroller is connected with a driver circuit. So we will find out, we will need, okay, this is the example. You can see here, your load, your light can be connected here. And this is your switching device. And you are connecting your microcontroller to this switching device. So whenever you are giving the pulse to this switching device can be turned on. During the on time of the pulse, this will be turned on. That means current will flow through this switch and through this load. So that means if you change the on time from these pulses, then this switch will be on for small duration and your load will get the voltage for the small duration of that time. So that means I can connect the higher voltage through this switch, and this switch will be working as an interface between microcontroller and these high voltage devices. So that what we do in our industrial application. We will